Hello everyone and welcome to this channel. In today's video, we'll be looking at an introduction to BioPython. There would also be a practical session where I would be walking you through on how to get started with BioPython on your PC. Well, this is actually the first video in our playlist, BioPython. So before we proceed, it is important to note that all videos that would be contained in this playlist have a target audience. What that means is that they are not designed for the general public, as it might be confusing or even seemingly boring to some of you. But if you're already in the field of bioinformatics, or you wish to pursue a career in bioinformatics and you want to learn how you could effectively utilize the BioPython programming tool in carrying out bioinformatics tasks, then this video is primarily for you. Nevertheless, if you still desire to watch this video for fun or to see the extent of our work, then you are welcome as well. Well, I'll be your host for today. My name is Malcolm Chikadibia Iheremelam, and this is Malcolm's Anatomy. Let's get started. Welcome back, guys. As mentioned in the intro, there's a relationship between BioPython and bioinformatics. So it would only be proper for us to give a kind of surface touch on what bioinformatics is and also talk about its relationship with BioPython before moving into BioPython proper. Let's do that, shall we? Bioinformatics, as the name implies, bio, which indicates life, and the informatics, you talk about statistics, you talk about computer science. So these three disciplines are combined to analyze and interpret biological data. That's basically what bioinformatics is. It actually has a crucial role in the field of genomics, which involves the study of the complete set of genes or genome of an organism. This is actually a basic definition of what bioinformatics is, but due to our time and the purpose of this video, we are going to leave it at that. Now, what is BioPython and what is its relationship with bioinformatics? BioPython is an open source software library that was created using the Python programming language. It is designed to enable the computational analysis of biological data, providing a complete set of tools, modules, and libraries that are specifically tailored for bioinformatics tasks. So, simply put, the relationship between bioinformatics and BioPython is that BioPython is serving as a powerful toolset in which bioinformaticians use to effectively carry out their bioinformatics tasks or analysis. It comes with a wide range of functionalities. For example, what we call parsing of biological sequence data, such as DNA, RNA, and protein sequences. So whether you are a biologist, whether you are a geneticist, or whether you are just a programmer who is interested in biology, then BioPython is a valuable tool for you. Now, one of the key strengths of BioPython is the fact that it supports different file formats in bioinformatics. For example, we have file formats like FASTA, we have file formats like PDB, we have file formats like GenBank. Now, BioPython supports all these formats and more. So with BioPython, you could easily write, read, or parse these files, making it an efficient tool when it comes to working with biological sequences and data. Another key strength of BioPython is the fact that it has a wide collection of algorithms and tools. Now, these algorithms and tools are not just efficient, they are also accurate, helping a researcher to gain valuable insights from his biological data. We have certain modules, or we have what we call modules in BioPython. For example, we have modules like SEQ, we have modules like SEC-IO, we have modules like Align, we also have Philo. Now, we're not going to explain these modules at the moment, but as we progress in this video and other subsequent videos in this playlist, we are going to come to understand how we could work with these modules when getting started with BioPython. Remember that the library of BioPython is actually still evolving, so there can still be change or addition in the future. Now let's take it at this point to the next session, which would be a practical session of BioPython, how to get started with BioPython on our system computers. Now that will be a practical session we would like to dive in, and let's do that right away. We are in my computer, and what you can see is the desktop screen of my computer. Now, to get started with BioPython, the first thing we have to do is to install some programs. Now, the first program we would install is Python itself. To do that, I have placed a link in the description of this video that will take you to the official site for Python, where you could download the Python program that suits your operating system. So when you open the site, it looks something like this: python.org. So I won't go through the necessary steps on how to install Python because of our time. So if you are finding it difficult to install Python, you could check on YouTube for other tutorial videos that could guide you on how to do that. Now, after installing Python, the next thing you do is to install BioPython. And to do that, you can use either the command prompt or the PowerShell. For me, I'll be using the PowerShell, a powerful shell, inbuilt shell in Windows 10. So I'm launching my PowerShell. You could just search for PowerShell using the search bar below here, and you get it. So this is my PowerShell. Now, to install BioPython, there is a command line I'm going to type into my PowerShell to start the installation process. And mind you, you only do this after you have installed Python. And secondly, you need to have your computer connected to the internet to get this process running effectively. So the command I'm going to type in is pip install BioPython. That's the command, pip install BioPython. So I click enter to execute this command. Let's see. Now you could see that the response I'm getting here is requirement already satisfied. I have two responses: the first, requirement already satisfied for BioPython, and the second, requirement already satisfied for NumPy, a different program that will also be installed alongside BioPython. But the reason why I'm getting this response is because I already have BioPython and NumPy installed in my PC. So for those of you installing it for the first time, you're going to get quite a different response. You could get something that looks like this. So after typing pip install BioPython, you get a response collecting BioPython, downloading BioPython. Then you also see the second program which is being installed alongside BioPython, which is NumPy, and you see the size there. So Once the installation is complete, you get a success message which is saying successfully installed BioPython and NumPy. So also remember that if before now you have Python installed, you might get a different response when you type in the command pip install BioPython. You could see something that looks like what you are seeing on the screen right now. Yes, so if you get this response, don't be worried. All you have to do is follow the instruction there to update your pip, that is your Python package installer. You have to update it to the latest version. Then after that is done, you come and re-execute this command. That is, you retype this command I've just given you, pip install BioPython. Then you can now get the response we are expecting, which is a success message that BioPython has been installed alongside NumPy. So that's for that. Now we're leaving the PowerShell back to our desktop screen. So we have successfully installed Python, assuming, and we have installed BioPython and NumPy using the PowerShell or the command prompt. Now what's the next program that we need to install in order to get started with BioPython? The next program is what we call the Microsoft Visual Studio Code. The purpose of this program is to serve as our terminal or console for whatever code we are going to be working with. So to install our Microsoft Visual Studio Code, we are going to visit the website and you get something that looks like this. So depending on the operating system that you are using, you could download the program that suits your operating system. Those of you using Windows, those of you using Linux, those of you using Mac OS. So you could download the one that suits your operating system and you install. Now immediately you click on, for those of you using Windows, immediately you click on this, it starts installing, it starts downloading rather automatically. So I'm going to take a sample of that. Click on this Windows. For those of you using Windows, the same applies to other operating system as well. So you can see it's saying thanks for downloading VS Code for Windows. So the program is downloading already, as you can see up there. But I'm going to stop this because I already have it downloaded and installed. I'm going to stop this. So after download, you install the program. It's quite easy. So you go through the steps to install the VS Code on your PC. Now another important thing for you to download from this same website is what we call the Python extension. And this is it here. So the Python extension is another very important program for you to install. So after installing the Python extension, it's going to open up in your Visual Studio Code. Now remember that you have to install your Visual Studio Code first before downloading this extension. So once your extension is downloaded, it's going to open up in the Visual Studio Code and you get something that looks like this. When you open the Python extension, you download the Python extension and you open it. So this is how it's going to look like. So it's going to ask you which of these extensions you want to download. So you're going to select the Python extension there that has a verified badge from Microsoft. You can see it at the top. So you click on install and it starts installing. So after that, you are going to get your Visual Studio Code looking just like this. So we have talked about the necessary programs we have to install in order to get started with BioPython. The first program, like we mentioned, is Python itself. I will drop a link on the description on how you could download the program from the official website of Python. And also the next thing you do is to install BioPython using either your command prompt or PowerShell or whatever shell that is running on your PC or operating system. And the next thing you do also is to install Microsoft Visual Studio, which is what we are seeing here. to install Microsoft Visual Studio and also the extension for Python. You have to install that as well. So when that is done, you are ready to get started with BioPython. So now that we have installed all the necessary programs, we want to get started with using BioPython. One of the first things we do, we could create a folder or a directory where we could organize and save the files we will be working with. Now you could give the folder any name you want. Mine would be BioPython 1. So to create my folder, I go to my file explorer and I create a folder here, and we have the name BioPython 1. I'm going to give the name Bio, or let me just say BPython 1. BPython 1. I click enter. So I've created a folder that has the name BPython 1. So what's the next thing? Now the next thing is to create an empty Python file, and that would contain our codes. Now you could also decide the name of the file. Now the name of my own file would be biofile1. Biofile1. So where do we create this empty Python file? You create it inside this folder that you have just created. Mine is BPython 1, remember. So I'm opening the folder I just created, and I want to create an empty Python file. And how do I do that? I use a notepad to create an empty Python file, text document, and I give it the name biofile1, rather biofile1. Enter. Let's open this with notepad so we can convert it to a Python file. So this is the empty Python file. You can see that there's nothing inside, so you click on file, you click on save as, then you give it the extension .py. .py. Now when you do it this way, it actually changes to a Python file. So I click on save, and you can see we have our empty Python file. So I could delete this text file now, and this is my empty Python file. Now the next thing is to place the sequence data file you want to work with inside this folder as well. So whatever sequence data file you want to work with, be it DNA, RNA, protein sequence, you have to place them inside the folder you created where you have this empty Python file. So in my own case, I will be working with a DNA sequence file. The DNA sequence file is DNA topoisomerase 1. I already have it downloaded. So this is the sequence file I want to work with. This. So what I do is I take this file from here and I place it inside this folder containing my empty Python file. So this is the sequence data I'm working with. So if you look carefully, you will see that this file is in the FASTA format. It is in the FASTA format. Now remember, we mentioned that one of the strengths of BioPython is that it has the ability to support different file formats. So FASTA is one of those formats. And so we also have formats like GenBank, PDB, and so on and so forth. So this particular DNA sequence file I'm working with is in the FASTA format. Now some of you might wonder how to get your sequence file to work with. Well, I will drop a link on the description where you could get direct access to 2 websites where you could download your sequence files in whatever format you want. So let's go to one of these sites so you could see a quick guide on how to download a file in a faster format. The website we are working with is a subdomain for the US National Library of Medicine. It is known as the National Center for Biotech Information, and this is the site. So now that you're in the website, what you do is you search for the name of your protein, your DNA, RNA, whatever biodata you want to work with. You search for it here. So let's assume searching for Homo sapien DNA, and we search. So let's click on nucleotide. So whatever biodata you want to work with, you should already know, and you search for it here, and we have so many options here. So to download your file in the faster format, whichever one you want, you click on that particular one. For example, I'm clicking on the first available sequence here. So you could see where it is written faster here at the top. So if you click on that, you can have a view of the faster sequence, or this particular sequence in the faster format. And this is how it looks like in the faster format. So to download this, all you have to do is you come here, you click on where we have send to. When you click on send to, then you click on file, then you select the format, which is already in faster since you have opened the faster link. So it's already in faster, so you could change the format if you wish, from faster to other. We have GenBank, we have other formats here, so whatever one you prefer. Then you click on create file. Immediately you click on create file, then the program starts downloading. Now one thing you need to know is, for example, when I downloaded this particular DNA topoisomerase sequence in faster format, when I downloaded it, it didn't come with this name. Rather, it came with this was how it looked like. This was how it was looking like, sequence.faster. So what I did was I had to rename it. So you can just simply rename it in order for you to easily identify the file you are working with. So I renamed it to this DNA topoisomerase 1, so I could easily identify the file I'm working with. So now in our BioPython 1, or let's say in our bpython 1 folder, we have 2 files. We have an empty Python file, which is biofile 1. Then we also have a faster file, which is DNA topoisomerase 1.faster. So next we are going to go into our working environment, which is the Visual Studio Code. Now what we will do now is to import the folder we created, that's this folder, into the Visual Studio Code. So I'm going to open the Visual Studio Code. So this is my Visual Studio Code. Now I'm going to click on open folder. Remember, we are trying to import the folder we created. Now we have 2 folders here, and I'm importing bpython 1. That's the folder I want to work with. So I click on that and I click on select folder. So we have my folder open here. You can see bpython 1. Then you have the content of the folder. we have the BioPython1, the empty Python file we created, and we also have the faster file. So if you click on the BioPython1, which is the empty Python file, then you have access to a terminal. This is a terminal, an empty space where you could write in file. So whatever code you are writing will be contained inside this BioPython1, this empty Python file you just created. So you could also click on the faster file to look at its content. So this is the faster file of this particular sequence file I'm working with. This is how it looks like. So usually every faster file starts with a greater than symbol. Then you can see an ID, the name of the file, and you can see the sequence. That's for the faster file. So we're going back. I'm clicking once again the BioPython1. So now we want to import some modules into this Python file. Now remember, we said that there are several modules in BioPython, and one of those modules is what we call seek. So we are going to import the seek module, and this is the code for it from bio.seek. Remember, you type exactly, take note of the caps, import seek. You click enter. So now once you've done that, you can take a variable. I'm using DNA as my variable since I'm working with a DNA sequence. So in my line 2, what I'm typing in is my variable DNA, and I'm giving it this seek. Then remember your brackets and your double quotes. And now you type in the sequence you would like to use. So let me just give a random sequence here of the base pairs of DNA, right? A T G C A T G C G C A T G T C G. This is just a random sequence. So now I can check if I have written this correctly by printing this sequence. So I want to print this sequence, and what I do is this, move from caps lock, print bracket and DNA. Now we click on run. Now you have run here at the top. You also have this icon that indicates running your program, so you could use either one of them. So we click on run. So you can see the results. So whatever we have typed here, whatever sequence we have typed here, it's actually correct, because here you can see the result it has given us. This is the result. So it is correct. Now, since I already have the sequence, I want to do another thing, and that is making a complement pair of the sequence. So this is very easy in BioPython. Assuming I was using normal Python, I first need to put a reference table, and from that I need to match out A to T, G to C, and T to A, and C to G. And after that, I need to call in that reference table and give in my sequences, an argument, which is going to give me back the references of the sequences in a string format, which is going to be my complement sequence. You see, this sounds very complicated. So to simplify that, you could use one thing in BioPython. And what is that? Print DNA dot complement. Then remember to put an empty bracket in order not to get an error message. So that is it. So what we do now is we click run. So looking at your terminal, you can see your sequence here, and also you can see the sequence complement. This is exactly how it looks like in base pairing. So another thing we could do is to create a reverse complement of the DNA sequence. Now this is actually a complement in a backward manner. So let's see how we can do that. So we have print DNA reverse complement. Then remember to put our empty brackets. So we run this and let's see how the reverse complement of this DNA sequence looks like. Now this is it. So we have 80 at the beginning here. We have 80 at the beginning here. Then here we have 80 at the end. We have CG at the end here, and here we're having CG at the beginning. So that is what we call the reverse complement of this DNA sequence. So this is one of the things you could do with BioPython. Now moving on, another thing you could do in BioPython is to work with FASTA files. So not just FASTA files, you also have GenBank files and the rest of them. So in order to work with a FASTA file in your terminal or console, you need to import another module from BioPython. And this time around, we are importing the seek.io module. And this is a little bit different from the seek we worked with. Now to import the seek.io, what we do, we use a different code from the one we used for importing seek. Now what we do is from bio, remember the capital letters, space, import. Import, then seek.io, IO in capital letter. So IO, which stands for input and output, because you are working with input and output files. So next you need to pull in a for loop. So to do that, we use this for sequence. I'm using sequence here as a random variable, which will only work inside the for loop. So we have for sequence in seek.io dot pass, because we are passing the files. So do not worry, you do not need to memorize or remember all these codes. The documentation of BioPython sort of gives you everything. So you could just refer to the BioPython documentation on the website, of which I'm going to put a link on the description, and you will get everything. The codes, how the output is going to look like, what it should give, and everything. So we are still on line 8. After that, we put our brackets and then we type in the name of the file, the FASTA file, that is this FASTA file we want to work with. Type in the name, and that is DNA topo isomerase 1 dot FASTA. Always remember to put the extension as part of the name. And after that, the next thing we are going to do is to add a second argument, and the second argument is actually the type of file, which is FASTA. And finally, one last thing we're going to do is to add the colon, since we are working with the for loop. And there it is. So enter. Going to for loop. So this is the name of the file and the file format, then your colon to indicate that you are working with for loop. So the first thing I want to do is to print out the ID of the sequence. That's this DNA topoisomerase 1 sequence. I want to print out the ID. Secondly, I want to print out the representation of the sequence. And lastly, I want to print out the length of the sequence. Now, how do we do that? Using the print function, print the sequence dot ID. Now that is going to print out the ID of the sequence. Then to print out the representation of the sequence, we use this code REPR, then sequence dot seq. And lastly, we want to print out the length of this sequence. So we have this for length of the sequence. So that is it. So let us run this code and see the response we are going to get. So you can see the result in our terminal. So we have here the sequence ID, and here is the representation of the sequence, although it was not given to us in full, but that's the representation of the sequence. And here lastly we have the length of the sequence. Now if you look at the ID, let us check if it actually tallies with what we have on our FASTA file. So if I open the FASTA file here, and this is the ID at the top here. Is the ID, and it actually corresponds with what was given to us here. And also we have the representation MSG. It tallies with what we have there. And lastly, we have the length as the characters of the file. So there are lots and lots of other things that you could do with BioPython. Tons and tons of functions, methods you could use in BioPython, and you can check them out in the documentation, of which I'll be keeping a link in the description of this channel for you to access it. So try them out and let me know if you have any questions. You could share with me your experience with BioPython, what you are working with and all. I have had fun sharing this video with you, and I hope that you benefited in some way. Please subscribe to this channel, as we would post more videos regarding BioPython. Don't forget to like and drop a comment. If there's any question, you could also drop it on the comment section. So that's for that. See you guys in the next video. Bye.